Hello students, this is an overview of the EETMECH 100 system that I demonstrated in the video demo that you should have seen before this one. And what we're going to be doing is looking at some of the diagrams, the electrical and pneumatic diagrams, and really look at each of the components of the system, at their function and how they are connected electrically and how they behave, how they interface with the PLC. There's a homework assignment that you're going to be doing, which is the online part of this week's module. And if you go to Blackboard, it'll look something like this. I'm still working on it, so it might be a little different. But you've got a homework handout with a series of questions that you need to answer, and you'll be needing the documentation of the system to answer those questions. They're based on the electrical and pneumatic diagrams. So those diagrams are all in the zip file, which you'll find also under the assignment. And if you download that zip file and open the folder, you'll see a series of files, spreadsheets, diagrams, and some subfolders with some of the modules in the system. So that's what I'm going to be going through in this PowerPoint. So if you want to kind of follow along, you can have those either opened up or printed out, or however you want to do it. And they look kind of like this. This is the electrical and pneumatic diagrams that we're going to be going through. There's one diagram for the power circuit, another diagram for the inputs, another diagram for the outputs, and the fourth diagram is the pneumatics. It's kind of a miniature of the HAS 200 diagrams. We just have one page for each, but they're split up in the same way: the power circuit, inputs, outputs, and pneumatics. All right, so let's get started. So as I mentioned in the demo, the purpose of this system is to sort colored objects, and we're using Legos. They're just uniform sized objects, so they're easier to work with. So this is a capstone project for the course ELM258 Mechatronic Systems. It's also a capstone for the Electronics Engineering Technology program, because many of the technologies and topics that you've studied in various other courses are part of this system. So some of the things you're going to see that are subjects you would have seen in other courses are PLCs and HMIs. In this case, we're using the Siemens platform, but if you've done Allen Bradley PLCs with some HMIs, then you'll find that there are a lot of similarities. You also see DC motor control, which involves things like using H bridges for bidirectional control, and also pulse width modulation as a way of varying the amount of power delivered to the motor and therefore the speed of the motor. You'll also have in the DC motor control optical encoder attached to the motor, and using the encoder signals, channels A and B, to be able to detect the speed of the motor, the position of the motor, and the direction that the motor is moving. We also have microcontrollers used in the project. There's a color detector which feeds its signals into an Arduino microcontroller, and then the Arduino interprets the color values, figures out what the color of the object is, and then tells the PLC what to do accordingly. So this is an Arduino-based RGB sensor system. There's also just basic electricity and electronics: switches, current flow, insulators, conductors, and so on. There's AC power coming into the system. It gets converted to DC power using two different power supplies, one for 24 volts and the other for 5 volts. And there are transistors used in some of the interface circuits to transform some of the different voltage levels, like a 5 volt signal into a 24 volt signal, for example. And then added to that, we have pneumatics, for two of the moving parts, the actuator that moves up and down and the gripper fingers. Many of the parts that are on the system were made in the Fab Lab using 3D printing and CAD. There are also various mechanical parts. The motor is attached to a lead screw that translates rotational motion into linear motion. There's a conveyor that's made up of a bunch of O-rings in parallel and a belt and a pulley system to connect the motor to the conveyor. So a lot of technologies and components integrated together, and that's the purpose of the system, is to provide a useful system that integrates these concepts. So let's take a look at the major components of the system. So starting here, we have the power entry module, and that's just a place where a standard power cord plugs in and plugs into a 120 volt AC standard power outlet. There's also a switch on that power entry module and an LED that gives you an indication that the power is applied. The wiring from that comes into a terminal block to carrying AC voltage. So this on the upper left, the red section is where the live voltage is, and those are insulated and covered over with a little warning safety cover. Then the green and yellow blocks are all earth ground for various earth ground connections, and then the lower terminals on the red block are the neutral lines. And there's a 24 volt DC power supply, so that gets AC power as an input and puts out 24 volts DC. We're using that to supply 24 volts DC to the PLC and also to the Ethernet module, and it also supplies the power to the actuator and also the conveyor. So that's actually a lot of different devices. Normally on a larger PLC system, you would have one supply to supply the lower current DIN rail and the PLC type components, and then a separate 24 volt power supply to supply motors and actuators, solenoids, things like that. But since this is a small compact system and we tried to make it desktop sized, we decided to just use the one power supply. So the next one component is the Siemens PLC. It's a Siemens S7 1200 series. Then there's an Ethernet switch which ties together the PLC, the HMI, which is over here, and allows a connection to a computer for loading software. Then there's the main terminal block where the input wiring and the output wiring comes in, and a pneumatic valve manifold. And just like the manifold on the HAS200, there are orange buttons that can be used to test just the pneumatics without having to supply an electrical signal. So there are 3 pneumatic valves. 2 of the 3 are used, and one is there as a spare for future expansion. One is for the linear actuator and one for the gripper. There's an entry port for the compressed air and a manual valve that can be used to turn that off. There's a pressure regulator to take the pressure from the room, which is at about 100 psi, and it regulates it down to about 40 psi for the system. There's a platform that's designed to hold the Lego in place for the arm to come out and grab it. That platform was made in the CAD lab by students. There's the vertical actuator and the gripper assembly, a conveyor to move the parts down to the sorting bin, the part bins, and that was actually made about a year ago by another group of students in the Fab Lab also. Then there's the motor for the conveyor, DC motor with a gear so the motor itself is spinning pretty fast, and it's geared down. I'm not sure how much, but it's geared down so the actual rotation is a lot slower. There's a few push buttons, just a green and a red and a selector switch. The Siemens HMI unit for creating virtual buttons and readouts and animations. There's the actuator. We're calling it the bug actuator. That's the nickname for it, the company. That actuator includes a DC motor, which has an optical encoder attached to it, and the motor is attached by a belt and a pulley to a lead screw. And as the lead screw turns, this actuator moves out and back. And there are two limit switches, magnetic reed switches, on the actuator to tell whether it's at its extended extreme or retracted extreme. And those are used to make sure that the motor isn't driven past that limit. Then there's the bug actuator interface, which has an H bridge and has some interface circuits for the encoder signals. All right, so we'll start with the power circuit. This shows all the components, the power entry module bringing AC in. It shows the connections to the Siemens 24 volt DC supply that's supplying all the major components on the system. And it also shows connections to a 5 volt supply, which is there to supply the microcontroller board, which has the RGB controller on it. So you have the Siemens PLC getting 24 volts, the Ethernet switch getting 24 volts, the bug actuator interface takes 24 volts, which it then supplies to the H bridge and eventually to the motor. And then the HMI also runs off of 24 volts. So let's look at the power entry module first. We have a standard power cord receptacle. There are spots for 2 fuses. There's only 1 spot being used, so there's a fuse in there to protect from high current. You can see here in the picture there's an LED indicator which shows you that power is on, and that LED is just placed between the live and the neutral lines. So that's all built into the AC power receptacle. And there are 3 terminals. They're actually blade terminals that are connected, that have wires connected to them, and those come out into the system and connect to the main power terminal block. So as I mentioned before, the red terminal blocks are carrying live on the top and neutral on the bottom. It's a double level terminal block. And then the green and yellow terminal blocks. Green and yellow is a standard safety color indicator for ground. So those are actually connected. The screws that fasten those to the DIN rail actually make contact, electrical contact, with the chassis of the equipment. So that is earth ground, which is connected through the power cord, but also earth grounds the entire metal chassis of the equipment for safety reasons. All right, so there's the AC power terminal block, and so the live is on the top, neutral is on the bottom, and earth ground the yellow and green. So those AC wires are connected to the power supply. You can see here live L1, N for neutral, and earth ground. And the other side of the power supply has the 24 volt and ground connections. Now Siemens is a European company, so they use European letter designations. The 24 volt output is designated as L plus, and the ground is designated with the letter M. And so for the purposes of the diagrams, we're using wire number 25 for 0 volts and 24 for 24, just like on the HAS200. So you can see the wire labels here. 24 and 25 are the 24 and 0 volt connections. So there's the 120 volt AC input, 24 volt DC output. There's also a 5 volt power supply. Now the live and neutral are the wires coming here on the bottom, and the wires coming out the top are 5 volts and 0 volts. So this is the symbol showing the 120 volts connection coming in and 5 volts going out.